Unsupervised learning refers to methods that learn from data without labeled outputs. Instead of being told what the correct answers are, the system explores the structure of the data itself. This video explains how unsupervised learning works and why it plays a distinct role in AI. Unlike supervised learning, unsupervised learning has no ground truth labels. The system receives only raw inputs and must infer patterns without explicit guidance. Unsupervised learning exists because labeled data is often unavailable or too expensive to produce. Many datasets contain valuable information but lack predefined outcomes. The defining difference from supervised learning is the absence of target variables. There is no direct error signal telling the system what is correct. The input data consists only of observations. The system must organize this data based on internal criteria rather than external instruction. The learning objective is to uncover structure. This may involve grouping similar items, identifying regularities, or detecting unusual cases. Pattern discovery lies at the core of unsupervised learning. Similarity and proximity guide how data points are related. Clustering is one of the most common unsupervised techniques. It groups data points based on similarity measures. Common clustering algorithms include k-means and hierarchical clustering. Each uses different assumptions and distance measures. Clusters represent groups of data with shared characteristics. Interpreting what those characteristics mean requires context. Distance metrics define similarity. Different choices can lead to very different clustering outcomes. Feature representation strongly influences results. Poor features distort similarity and reduce meaningful structure. Dimensionality reduction techniques compress data while preserving important structure. This simplifies analysis. Reducing dimensions helps with visualization, noise reduction, and computational efficiency. Principal component analysis identifies directions of maximum variance in data. It is widely used for linear reduction. Manifold learning methods capture nonlinear structure. They assume data lies on lower dimensional surfaces. Density estimation models describe how data is distributed in space. This supports anomaly detection. Anomaly detection identifies rare or unusual data points. These often signal errors, fraud, or novel events. Unsupervised learning is commonly used for exploration, segmentation, and preprocessing. There is no single correct answer. Results depend on assumptions, parameters, and interpretation. Evaluation is difficult without labels. Traditional accuracy metrics do not apply. Validation often relies on human judgment or indirect performance measures. Human interpretation assigns meaning to discovered structure. Domain expertise is essential. Unsupervised methods are sensitive to assumptions such as initialization and parameter choices. Scaling and normalization affect distance calculations. Poor scaling distorts patterns. Noise can create false structure. Robust preprocessing is important. Bias in data affects discovered patterns. Sampling bias becomes embedded in structure. In business, unsupervised learning supports customer segmentation based on behavior. In science, it reveals structure in complex datasets like gene expression profiles. In security, it helps detect anomalies such as fraud or intrusions. Visualization aids understanding. Reduced representations reveal hidden structure. Unsupervised learning supports hypothesis generation rather than final decisions. It complements supervised learning by improving data understanding and preprocessing. Limitations include ambiguity and interpretation risk. Overinterpretation leads to false conclusions. Patterns are not explanations. Computational cost increases with dataset size and dimensionality. Data quality strongly affects results. Missing or noisy data misleads models. Unsupervised learning does not imply understanding. It identifies structure, not meaning. Domain experts validate findings. Interpretation is a human responsibility. Ethical risks include profiling and misuse of group assignments. Unsupervised learning works best when structure exists, but labels do not. It works poorly with small datasets or weak signal. Compared to supervised learning, unsupervised learning focuses on discovery. Hybrid methods combine labeled and unlabeled data for efficiency. Modern AI uses unsupervised learning for representation learning. A common misconception is that unsupervised learning finds truth automatically. Its strengths include flexibility and discovery. Its limitations include uncertainty and evaluation difficulty. The core takeaway is that unsupervised learning discovers structure without labels. Next, we examine semi-supervised learning, which combines labeled and unlabeled data.